Hello everybody! Today we're going to be working on finding zeros of polynomial functions. So by the end of this video, you should be able to do the following things. I can use a rational zero theorem to find possible rational zeros. I can find real zeros of a polynomial, and once you've found those zeros, then I can decide if the zeros are rational or irrational. So let's go through a couple of examples, figure out some steps to work through. And as always, if you want to work through pieces yourself, you stop the video and work on it yourself and then join back in. So finding all zeros for polynomial functions. So we're going to start up at this one. So it says f of x equals x to the fourth minus x to the third plus 2x squared minus 4x minus 8. So what are some steps that we can follow to figure out all of the zeros? Well, first, let's determine the possible solutions using the number of possible solutions using the fundamental theorem of algebra. So let's check out the degree of this polynomial right here, and what is the degree of that polynomial? You are right, it's 4. If you're thinking, how do I know that it's 4? Well, you just look right here. It's in standard form, which means everything is in order by exponent from greatest to least. And so my degree is 4, which means there are going to be 4 zeros. Now, we don't know if they are real, if they're imaginary, if they're rational, irrational, but there will be 4 of them. So then what can I do after that? Well, then I'm going to figure out what are all of the possible rational zeros. So if you remember, when I'm trying to find rational zeros, I'm going to look at the end here. What is my constant? And what is my leading coefficient? Well, in this case, I don't see anything, so therefore you know it's right, 1. So I would like you to write down all of those possible rational zeros and then come back with me. So hopefully you figured out, hey, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now, since the leading coefficient was 1, really everything could be divided by plus or minus 1. So my possible zeros then end up being, or my possible rational zeros end up just being plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So a quick thought, I would like you in your head to try 1 and negative 1. Just because when you think about it, it would be really nice. So let's go right here. 1 to the 4th power would be 1, minus 1 to the 3rd power would be 1, 2 times 1, so plus 2, 4 times 1 minus 4 plus 8. So I quick do those in my head. Does that give me 0? Because my ultimate goal is if I plug in 1, does it give me 0? And so, nope, it doesn't. So that didn't work. But let's try negative 1 just in case. So if I look right here, negative 1 to the 4th power, positive 1. Negative 1 to the 3rd power, negative 1, but there's a minus, so that's 1. Negative 1 to the 2nd power is positive 1 times 2 plus 2. Negative 1 times negative 4 plus 4 and minus 8. When I put those together, did those equal up to 0? They do! So this tells me that negative 1 is going to be a 0. So that helps me in my synthetic division later. But right now, so I know that that is going to be an option. So then let's just check over here after I've determined how many zeros I'll have, find all the possible rational zeros. Now, because I have 8 possible here, I know that negative 1 is going to be one of them because I quick checked in my head. But because there's so many possibilities, I'm going to narrow down that list by using the graphing calculator. So would you pull out your graphing calculator and graph that and then come back to me? All right, here it is. I've typed it in, pull up my graph, and I look and I say, oh, wow. It looks like there's two places, -1. Ha! I knew that because I checked. And +2. Excellent. So I'm going to go back over here. I'm going to say -1 and +2 because that's what my graphing calculator said. So now I'm going to go back and I'm going to set up a synthetic division to see, okay, are these really zeros? And then after I do that, I need 2 more, so what are they going to be? So here we go. Let's set up our synthetic division. So here's my synthetic division started. I'm going to start with -1 just because I found it first. But really, does it matter what I start with? It doesn't. So you can choose. I'm going to drop down this 1. I get 1. -1 times 1 is -1. Now I add them up. So I get -2. -1 times -2, +2. 2 plus 2 is 4. -1 times 4 gives me -4. Add those up, I get -8. -1 times -8 gives me +8. Oh, look, it's a 0, just like it thought. Yes. Okay, so now I know that that is a 0. So now I'm going to put in my 2. And I can just keep going. So I drop down my 1. 2 times 1 gives me 2. 0. 2 times 0 is 0. 4. 2 times 4 is 8. Yes! I've got it again. So now, what am I left with right here? This right here is, I've gone down, I went from x to the 4th, x to the 3rd. So I'm at x squared plus 0x plus 4. So that looks like this. Now, if I wanted to pull the whole polynomial apart, I could write x minus 2, because if the 0 is +2, if you have a gain of 2 yards and a loss of 2 yards, that puts you back at the line of scrimmage. So right there, that's why I'm putting -2 to undo that 2. And then x plus 1. So this is my factored trinomial. I know I have a 0 of 1 from right there, or -1 from right there. 0 of +2. Right here, though, what could x squared be that would make -4? Well, some of you are thinking, oh, there's an I. Yes, there's an I. However, we're not going to go there until tomorrow. Right now, we're just looking for, let's just look for real roots. So I'm going to go with -1, +2, and then I'm going to say the other 2 are imaginary numbers, which we will work with that at different time. So let's try this next one. As I go through, find all zeros. So find all zeros for this one. Now you may be thinking, hey, wait a second. Before you gave me this list and you got so excited solving the problem you never went through the whole list. Darn it, you are right. So let's quick go back, review the steps. We determined the number of possible solutions using the fundamental theorem of algebra. Then we found all possible rational zeros. We narrowed the list down by graphing, and then I just started synthetic dividing. That was number 4. Verify a 0 by doing synthetic division, and then repeat the process, which is exactly what we did, until we get down. I always go down to an x squared, and then I try some other methods. Well, in this case, it was x squared plus 4, so I knew, we've got some imaginary solutions. So now let's come back to this one. 4x to the 4th minus 17. So I would like you to go through and find all of your possible rational zeros. I know because of my leading coefficient and my constant that my possible zeros are positive -1, positive -2, positive -4, plus or minus 1/2, and plus or minus 1/4. So now go in and graph that. I could go in and check 1 and -1 by myself, but I'm kind of running out of time in my video, so you do that and then graph it and come back to me and see what you see. So when I look, I know by the fundamental theorem of algebra that I'm going to have 4 roots. So I look right here. Oh, look, It looks like -2, -1/2, +1/2, and +2. So let's try them and see if those really are what they should be. So I come back over here and I'm going to start writing. I'm going to be like, okay, so here it is. I've got 4, -17, and 4. At which point in time, hopefully you're saying, wait, she made a mistake. I did. What is my mistake and how can I fix it? Yep, I missed a 0 and a 0 because it's 4x to the 4th, 0x to the 3rd, minus 17x squared plus 0x plus 4. So I would like you to go and on your own, I would like you to do the synthetic division and prove to me that the roots should be -2, +2, -1/2, +1/2. So here's my work. Does your work match up? I found that 2 worked, and then I also found, so I found that 2 worked here, -2 worked here. And then I found that I had 4x squared minus 1. That's a difference of squares, so that breaks into 2x plus 1, 2x minus 1. And so here are all of the zeros. Now, are those rational zeros? Any of them irrational? Well, think back, rational means ratio, and so all of those numbers are ratios, so they all can be rational. I would like you to try one more on your own. Come on over here. Try this one. So x to the 3rd plus 10x squared plus 33x plus 34. I want you to pause the video, work through it, and come back to me with how many zeros should you have? Yes, you should have 3 zeros. Come back to me in a minute. If you need a hint, here you go. You know that there's going to be 3 roots. Your possible rationals are plus or minus 1, plus or minus 2, plus or minus 17, plus or minus 34. So I'm going to go graph it, and when I do, here is what it looks like. Well, there's only one at -2. So start with -2 and come back with me and see what you have. Alright, so I broke it down. -2 worked. Woo! But then I've got 1x squared plus 8x plus 17. Well, what multiplies to give you 17 and adds to give you 8? There is nothing. So start singing a little ditty in your head and have some fun with the quadratic formula. Come back to me in a moment with that work done. Well, I got a negative underneath the square root. What does that mean? Yeah, it means right now there's no more real solutions. Are there going to be 2 more solutions? There will be, but they're going to be imaginary. So today we went through and we found all of the zeros for polynomial functions. So we used the rational zero theorem to do that. We found our real zeros. Then we decided if the zeros were rational or irrational. Today we really didn't find any irrational. So all of the roots that we came up with were nice ones, rational. And then irrational would be if we had come up with a square root of 3, square root of 5, square root of 2. Really a square root that's not on the clock is basically what would have happened today. And so there you go. If you have questions, go walk through it again and we'll spend more time on it tomorrow.